Okay, so we have this question right here. It says a teacher used liquid nitrogen to demonstrate low temperature physics. The teacher dropped a peeled banana at room temperature into a flask of liquid nitrogen. Explain why the liquid nitrogen boiled when the banana was submerged in the liquid nitrogen. So it's a very simple question. First, we need to understand the temperature difference, right? So liquid nitrogen is like below 150 degrees Celsius. I don't know the exact number. And the peeled banana is like something like 20 degree to 30 degree, you can say Celsius. Okay. Now, what actually happens is that when you drop the banana into the liquid nitrogen, the heat energy is transferred, right? From the banana to the liquid nitrogen. And then since like the nitrogen is extremely cold and it's still in its liquid form, when this warm banana is added, the heat from the banana causes the nitrogen to start boiling up, right? And why this boiling happens, right? Even though the question says that there is like boiling happening, right? So why this boiling is happening? This boiling happens because the nitrogen absorbs the heat as latent heat. And what is latent heat? Latent heat is like changing state from liquid to gas without changing temperature, right? Similar as when you have ice at 0 degrees Celsius and it changes from solid to liquid, right? And still be at 0 degrees Celsius. Okay, so the same thing here as well. So first we will write the heat energy is transferred from the banana to the liquid nitrogen. Okay, now the second thing you will mention is that why this boiling occurs, right? The heat energy is transferred from banana to the liquid nitrogen, but I didn't still get it why it's still boiled, right? So then you will say that this boiling happens because the nitrogen absorbs the heat as latent heat. Okay. Okay, so we have this next part right here. It says during the demonstration, the liquid nitrogen remained at its boiling point in a large flask. The teacher estimated that at least 0.5 kg of the liquid nitrogen was needed to cool the banana from room temperature to the temperature of the liquid nitrogen. Assess the accuracy of the teacher's estimate. Okay, so the first step I always say is that identify the values you have. Okay, so what values do you have? I have latent heat of vaporization of nitrogen, so LV, and then I have boiling point of liquid nitrogen, which is TB, and the specific heat capacity, which is C, and I have M, and I have room temperature, which is TR. Okay, now what is your final goal? I always say, right, what is your final goal, right? Choose formula according to your final goal, right? So at the end, you're gonna use latent heat of vaporization's formula, which is E is equals to LVM, right? Because you need the mass, how much basically mass is required to cool down this banana, right? From room temperature to the temperature of liquid nitrogen. So we will use this formula right here, right? So if you arrange it, it will be M is equals to LV by E. Now I have latent heat of vaporization of nitrogen, but I don't have the exact energy, like how much energy do I need to actually cool down this basically banana, right? So in order to get that from the formulas, I could think of that I have specific heat, I have mass, I have the temperature change as well, right? From I need to go from room temperature to the boiling point of liquid nitrogen, right? So I could use the formula which is E is equals to MC delta T, okay? And then if I need the E, if I input the mass, right, it's 0.118, input the specific heat capacity of banana, which is 1.76 times 10 raised to power 3, and then you have temperature, which is the change in temperature, right? From room temperature to the boiling point. So it's 292 minus 77.4, right? And if you calculate this, you will get your answer as something 44,605.5 joules, right? And now if you input this energy, right, this energy is required, this much energy is required to cool down the banana from room temperature to the temperature of liquid. Now we have to figure out in mass, right, how much mass of liquid nitrogen is required. Okay, so mass is equals to LV. We have 1.98 times 10 raised to power 5. No need to write the unit right now. So, and you have E, which is 44,605.5, right? And now if you calculate the mass, it will be something like 0.225 kg, right? Something rounded off value. Now, if you compare this value with the 0.5, right, the teacher said it needs at least 0.5, right? At least means it should be equal to or greater than 0.5, but as you can see, we don't need that much. We only need 0.225 kg, right? So you can just say that, you can just simply say that 0.225 kg is less than 0.5. So the teacher assessment is not accurate, or is not correct, is not accurate. Okay,